Guys, today we're discussing the search insert position problem, and what this says is that if you have a sorted array like this, then given a target element, where would this be inserted, at what position? Okay, so in this case after the second position it would be inserted so that the array still remains sorted. Of course, here in case of this we would want to insert it after the first position, and in case of 7 we would want to insert it after the sixth element, right? The sixth number, the fourth element. Okay, perfect. So that's why we return 4. So this is the question. You could pause the video and solve. The hint is that we have to use binary search logic as it's given over here, and we're kind of doing that right now. So alright, let's move to the solution. So in order to understand the solution, let's first look at our binary search code. Okay, this is our binary search code that we have discussed in a video before this one. And what we basically need to focus on is this line. Okay, what does this line indicate? We return this line when we don't find that element in the array. Okay, so for example, if we have this test case 1, 3, 5, 6 as we just saw, and the target is 2, then what will happen is that we'll get -1. Okay, so that indicates that we did not find our element, right? And this also says that our binary search has narrowed itself down so much that it cannot find it, okay, and it cannot narrow down any further. So this sentence is important. When low is greater than high, it means we have narrowed down the search space so much that the target is not found. At this point, low tells us the position where the target should go. Okay, this is what is important. Okay, so if we return low over here, we will get the right answer. But in order to understand this better, we would want to actually debug that code. Okay, so let's quickly go to VS Code and look at this code. Okay, so what we are doing over here, let's first understand the code. Okay, oops, wow. Okay, so here we have our main method in which we are passing our nums. Okay, this is 1, 3, 5, 7, 11, so this is odd numbers, and we want to add 9 to it. So where should we add it? So we should add it after the first, second, third and fourth, at the fourth position, like after the fourth position, right? So POS should return 4. So we are passing this into this method where we have nums and target. We have passed nums and target, and we are going to put another method over here which is going to be a recursive method, and it's going to be the same code for the binary search, but we are going to return low. Okay, so let's quickly debug this code. Okay, awesome. So initially we are starting from here. Okay, our nums is our nums array. Okay, and target is 9. Okay, awesome. Initially we see that low is 0, high is 4 and target is 9. Cool. Low is not greater than high, so we are going to go forward. Mid is going to be 2. Okay, nums mid 2, so 0, 1, 2, 5. 5 is less than the target, right? So we're directly going to go to this third position. Since this one is for equal, this is for it being greater than target, like 5 is not greater than target, so we go to this position. Okay, and over here we'll find that our new low, okay, as we can see, our new low is 3 and our high is 4. Okay, again this condition is not met. Now mid will be 3. Mid is 3, same position as the previous one. Okay, and now our high and low both are 4. Okay, but still this position is this condition is not true, so we'll go ahead. Now our mid will be 4. Okay, and 4 means 11, so this time it is greater than the target, right? So we're going to pass this, and now our low was 4. Mid is going to be 4 again. See, yes, mid -1, so 3. So we can see that low is equal to 4, high is equal to 3. Okay, that's why we are going to return low, and that's going to give us 1, 2, 3, 4 after the fourth position. Now if we wanted to know the index, okay, after which we want to position it, then we would want to return insert position is 4 is correct, right? Because 0, 1, 2, 3, and then at the fourth position you want to insert 9. Okay, so that's still correct. Yeah, But if you wanted the index after which you want to insert it, you could do low minus 1. That's also fine, right? Okay. And wait, hold up. Okay, we're still on that one. And that's how we get our position is equal to 4. Okay, awesome. So I hope you've understood this. Okay, it actually gives a deeper understanding on what we are doing when we say that line. Okay, wait, where is that line? This line. In binary search, when we do -1, what it means. Okay, so let's go back to this code and quickly write it down. Okay, what did we do? The first thing that we did was that we said we will return our, let's call it search insert position. Okay, or let's call it binary search insert position. Okay, that's a huge name, but okay. And we're going to pass nums and target. Awesome. Now we're starting over here with our public static int and this huge ass name, which I'm just copy pasting. Okay, awesome. And it's going to be int nums comma int low comma int high comma int target, just like our binary search. The first condition is that if low is greater than high at any point, that means we haven't found the element, and the low is actually an indicator of where I should insert that element. Okay, rest of the code remains same. High minus low by 2. And what else? Yeah, now the if condition. So if nums mid, last time we did that mistake of just saying mid, which doesn't make sense. So if nums mid is equal to target, then we are going to return, what are we going to return? Mid. Yes. Else if nums mid is greater than target, then we're going to search in the lower half. So we're going to return this huge as name again, nums comma low comma mid -1 comma target. And the last line, else return nums comma mid +1 comma high comma target. Awesome. So that's our code, and let's quickly submit it. I hope we haven't made any silly errors. Yes, we have. Okay, static int method this in class solution cannot be applied to given types. Oh right, okay, yeah, here we need to pass this also, nums dot length -1. Yeah, that's silly. Okay, it is like a arguments mismatch kind of thing. Okay, awesome. And yay, awesome, cool. So that's our solution. Hope you understood. Thanks for watching. Bye.